In this video, I'm going to show that the sine of alpha minus the sine of beta is equal to 2 times the cosine of alpha plus beta on 2 times the sine of alpha minus beta on 2. And the two key results we're going to use to show this are the compound angle formulas, two of the compound angle formulas being the sine of A plus B being equal to sine A cosine B plus cosine A sine B. So we're going to take that as given. We're not going to prove that. We just rely on that compound angle formula. And the other compound angle formula we'll use will be the sine of A minus B being equal to the sine of A cosine of B minus the cosine of A sine of B. So using these two compound angle formulas, we will be able to derive this new result of sine alpha minus sine beta being equal to 2 cosine alpha plus beta on 2 sine alpha minus beta on 2. Now, the first thing to notice is that on the left-hand side we've got a sine alpha and a sine beta, just alpha and beta. Yet on the right-hand side we've got this alpha plus beta on 2 and an alpha minus beta on 2. And so what's worth doing is almost a preliminary step, like a side note, on how we can get from alpha and beta to alpha plus beta on 2 and alpha minus beta on 2. And I'll start with alpha, and we can note that alpha, whatever value it takes, is the same as just alpha on 2 plus alpha on 2. We've just taken that value and divided it by 2, so we've got the 2 halves. And then if I was to add beta on 2, and then subtract beta on 2, hopefully you can see that I haven't changed anything. We're still just left with alpha, whatever the value of alpha is. But if I just rearrange this slightly to say that that's alpha on 2 plus beta on 2 plus alpha on 2 minus beta on 2. So I've just reordered the items. And then if I note the common denominator, we can then write that as alpha plus beta on 2 plus alpha minus beta on 2. You can see how now we can go from alpha by itself to the alpha plus beta on 2 and alpha minus beta on 2, which we need for our right-hand side. So from there, we can actually say that, therefore, if we wanted to write sine of alpha, we can write that as the sine and then insert this result for alpha. So alpha plus beta on 2 plus alpha minus beta on 2. And from here we can use our first compound angle formula, thinking of alpha plus beta on 2 as being the equivalent of our capital A, and alpha minus beta on 2 as being the equivalent of our capital B. So in this first compound angle formula, wherever we see capital A, we'll just write alpha plus beta on 2. And wherever we see capital B, we'll write alpha minus beta on 2. So if we do that, we end up with the sine of alpha plus beta on 2 times the cosine of alpha minus beta on 2 plus the cosine of alpha plus beta on 2 times the sine of alpha minus beta on 2. So there we've done our first step in getting from the left-hand side to the right-hand side. We've taken the sine of alpha and we've written it in a format that has both sine and cosine and the alpha plus beta on 2 and alpha minus beta on 2, which we know we're working towards. So now what we'll do is we'll do a very similar thing for beta and then sine beta. So I'll just turn over. And again, we'll do a side note, this time for beta, to get beta in terms of alpha and beta on 2. So beta we can write as beta on 2 plus beta on 2. And then we can add an alpha on 2 and subtract an alpha on 2 and know that we haven't changed anything. And then if I just reorder that, we can write that as alpha on 2 plus beta on 2 minus alpha on 2 plus beta on 2. And then if I bring the common denominators together, we'll get an alpha plus beta on 2 minus, and here we need to be very careful with our negatives. So if I'm going to minus a single fraction, it would be alpha minus beta on 2, and that would ensure that we get the minus alpha and then the minus beta to be the plus beta on 2. So from there we can therefore say that if we want to think about sine of beta, we can write this longer form of sine alpha plus beta on 2 minus alpha minus beta on 2. And then we can use our second compound angle formula. So if I just come back, we've got this sine of A minus B being sine A cos B minus cos A sine B. And again, we can think of the, wherever we see, if I just flick back, alpha plus beta on 2, we can think of that as our capital A, and alpha minus beta on 2 is our capital B. So therefore, we can say sine beta is equal to the sine of alpha plus beta on 2 times the cosine of alpha minus beta on 2 minus the cosine of alpha plus beta on 2 times the sine of alpha minus beta on 2. And now we've got both sine alpha and sine beta in terms of these alpha plus beta on 2 and alpha minus beta on 2. So now we can bring them together. We can say, therefore, sine of alpha minus sine of beta, which remember is what we were focused on, that's our left-hand side. We can now insert these two results. So we'll have our sine alpha plus beta on 2 cosine alpha minus beta on 2 plus the cosine of alpha plus beta on 2 times the sine of alpha minus beta on 2. So that's just rewriting the sine alpha result. And then we've got this minus, so I'll say minus, and in brackets we write out the whole sine beta result. So sine alpha plus beta on 2 cosine alpha minus beta on 2 minus cosine alpha plus beta on 2 times the sine of alpha minus beta on 2, and that's all in brackets. Now, if we think about multiplying this negative through these brackets, we'll end up with a minus sine alpha plus beta on 2 cosine alpha minus beta on 2. And then the minus cosine would become plus. So if I just remove these brackets here, and there was a bracket there, but now I remove that, and we'll have our, we just end up with the minus sine alpha plus beta on 2 cosine alpha minus beta on 2, and then plus. This minus becomes a plus. Now from here we see that the sine alpha plus beta on 2 cosine alpha minus beta on 2 minus sine alpha plus beta on 2 cosine alpha minus beta on 2, those two will cancel each other out, and we're left with 2 of this second item, the cosine alpha plus beta on 2 sine alpha minus beta on 2. We've got 2 of those, so therefore sine alpha minus sine beta is equal to 2 of the cosine alpha plus beta on 2, sine alpha minus beta on 2. And if we go back to what we were trying to show, that is exactly what we were trying to show. So that is as required.
Sonic boom!
So there you have it for that result. Basically, we were using two of our compound angle formulas and also this neat technique of taking a single angle, the single angles that we had on our left-hand side, and converting them into the alpha plus beta on 2 and alpha minus beta on 2 to then get it into the format we needed. So somewhat straightforward, although perhaps not a technique that will jump out at you intuitively. Just the kind of idea that once you've seen it, now that you've seen it, hopefully it's something you can add to your toolkit when trying to work on these kinds of proofs. So hopefully that's all made sense. And tick boom.